Hi, this is John Sanchez, and this is my Week 6 video tutorial in an introduction to interactive programming in Python. This video is on object-oriented programming, which is one of the more difficult concepts of this week. Sometimes people call this OOP or even OOP. And here's a quote. It's written by me, but I'll say it anyway. Don't let your eyes droop when you hear OOP. Okay, that's the message. Let's keep going. I'm sure plenty of you have heard this before, but I'll say it one more time. Get to class! So what's a class anyway? A class is like a type, and each member of this type shares a common behavior, can do the same sort of thing. And most nouns in English are defined by how they're used, so this sort of makes sense. For example, pants are defined as articles of clothing that are used to cover one's legs. So pants would be the name of a class, since all pants can do the same things. They share the same behavior. And object-oriented programming is really just bringing together common pieces of a program into classes, and each class can work independently, providing different behaviors for types. And in Python, classes are defined with the lowercase word class, followed by the name of the class, which by Python convention is usually uppercase, or the first letter is uppercase. Now please, even if this is confusing, don't object, just listen. So what's an object? After a class is created, each member that is created under that class is called an object. So if I went to the store and bought a pair of pants, these pair of pants would be members of the pants class. And that pair of pants would be an object. And this object is sometimes known as an instance of the pants class, or an instance of a given class. And to create an object of a pants class, or really of any class, you say, in this case, new pair, but it could be any variable name. So new pair equals, I'm assigning new pair to this, which is the name of the class, or pants, and then any parameters that are required when defining an object of the pants class, which would be in the init method, which will be covered in a minute. Now this might sound a little bit crazy, what I'm saying, but don't worry, there is a method to my madness. Okay, bring it on. When creating a class, you define the methods of the class under the class declaration, the class pants, and then under that the methods go. And the methods are what define the behavior of the class. And to create a method, it's really just creating a function inside the class declaration. Now the first method that all classes need is the __init___ method. And what this does is it sets up all the variables and all the busy work that needs to be dealt with in the other methods, and that is called when creating an object of the class. And as I said, it takes as parameter whatever information varies between each instance of the class. And every method in the class takes a special parameter called self. And this self refers to the instance of the class that the method is being called upon. Okay, I hope that makes sense. Now let's go off to ColdSculptor and see this all in action. I think it helps when teaching something to refer to an example. So I'm actually going to build out a class called the book class, so you can see how objects, classes, and methods all work together to create the full picture of OOP. And then hopefully your eyes won't droop when you hear OOP. Okay, let's implement the book class. Now, like in the video lectures, I'm going to try to do this in one take so you can see my thinking process and what happens. So to start, we type out the class keyword and the name of our class, which is book. And notice how it starts in an uppercase letter. Now let's define some methods. As we said, the first method in every class is the __init___ method. And the parameters are in here are what varies between each instance of the book class. Okay, now we always need self, and that refers to the object that we're working on. And we're going to leave the rest of the parameters blank for now, so we can see what we need while writing the rest of the method headers. So I put a pass statement in the body, and we should probably be able to read the book. So I will say define read, and this read method take self, so we know what book we're reading. But also, it should take the pages that we read, the number of pages that we read. Put a pass statement here. And the final method that we'll implement for now is getPage. And getPage takes the book that we want to get the page we're currently on of. And then that should probably be it, because that's all we need to get the page, the book we're on. Okay, so now if we're going to get the current page, we need to keep a record of what page we're on. So this can be accomplished by creating a field or an attribute of each book instance inside the underscore underscore init underscore underscore method. So to do that, we type self.currentPage equals 0. Now let me explain this. So self.currentPage defines a field of each book, and this sets it equal to 0. So every time we initialize a new book, we take the current page and set it to 0 because we haven't started the book. So now the get and this field can be accessed throughout any of the methods within the class. So now here we can just say print you are currently on page plus self.currentPage. Okay, and with this self.currentPage field, it should also be pretty easy to read. So we can say self.currentPage plus equals pages read. I'm going to change the parameter. So this basically says take the old version of self.currentPage, its old value, add it to pages read, which is the parameter, and then reassign that back into self.currentPage. Okay. Now let's define an instance of the book class. So to do this, we say variable name. I'm going to say catcher in the rye. Oops. Catcher in the rye. And that is equal to, we say the name of our class, which is book, and then any parameters that are listed inside the underscore underscore init underscore underscore method. In this case, all that is there is the self method, but that is defined implicitly when we set this variable name. But self here refers to catcher in the rye. Okay, so this is all we need. Now let's try returning or printing out the current page we are on. So we'll use the getPage method. So to call a method, we say object name, which is catcher in the rye, dot, that means we're calling a method, dot getPage, that's the name of our method, and then any parameters that are listed inside the method that we're calling. Here it's just self, and again self refers to catcher in the rye, which is defined implicitly, so we can leave these parentheses empty. But always remember to include the parentheses, even if you don't need to put anything in them. If you don't, it could cause some problems within your program. So always include the parentheses. Okay, so let's see what we get. You are currently on page 0. Wow, it works. No surprise there. So now let's try reading the book. So again, we're going to say object name, catcher in the rye, dot read. And here, there are two parameters that we need. Self, which is catcher in the rye, and pages read, which we actually need to put inside the parentheses. So let's say we're on our reading roll, and we read 134 pages. Okay. So if we run that, we don't get any results, but this self.currentPage field is actually, behind the scenes, increased to be equal to 134. So now we can say catcher in the rye, object name, dot getPage, one more time, and we can see that we are now on page 134. Great. Now, before we wrap up, I want to define one more method, get some room, called am I done? Am I done with the book? And this will just take self. But what I want this one to do is when I call this, the computer will return what if I'm done with the book or if I'm not done with the book. And to do this, we're going to use a conditional in here. So if self.currentPage is greater than or equal to the number of pages in the book, but we don't have that anywhere. This would be a great thing to put as a parameter in the underscore underscore init underscore underscore method, because this is one of the things that varies between each book. Perfect. So we have self, and then we also have pages total. Pages total. So if we can say if self.currentPage is greater than or equal to, well, actually, we need to define a field that uses pages total in the underscore underscore init underscore underscore method to make pages total accessible to this method, to the IAmDone method, or the MIDone method. So to do this, we say self.pages total is equal to pages total. And the pages total on the right side of the equal sign and the one on the left side of the equal sign refer to different things. The one on the left side of the equal sign is I'm defining right now, and it's a field of self, or the object that we're talking about. The one on the right side of the equal sign refers to the parameter that we passed into the underscore underscore init underscore underscore method. Okay, so now we can say if self.currentPage is greater than or equal to self.pages total print you are done with the book. Else, how about we print how many pages are left in the book? So we can say you have plus so to find the number of pages left in the book, we say pages total, or self.pages total. Gotta know what book we're talking about. Self.pages total minus self.currentPage. And this will give us our value. But we have to make sure to put this in the stir function so it doesn't throw an error. Plus pages remaining. Okay, finally. Now let's go back to our objects and see what we need to fix. I'm going to make some room down here. Now, we added a parameter to the book class, to the underscore underscore init method. So pages total. So in Catcher in the Rye, there are about 275 pages. I'm estimating there. So we need that now. So if I run this now, it should still work with the value, as long as we add that there. Okay, so it still works. Now let's try using the MIDone method. MIDone. So remember to do this, we have object name Catcher in the Rye dot object name, or object name dot method name parentheses, and we don't need anything in the parentheses. And this should print no and give us the amount of pages we have left. So let's see it work. Oh, we called MIDone. Okay, so no problem. So now we run it, and it says you have 141 pages remaining. Sorry about that. Okay, now if we say we actually read 278 pages, bye. Hasty typing. It's my fault. Okay, so thank you for watching.